Now let us see the concept of vectors. So far whatever the physical quantities we have in physics, okay, they are divided into broadly two types. First type of physical quantities are known as scalar and next type of quantities are known as vectors. In the given concept, what is meaning of a scalar and what are the properties and what is meant by vector, what are the properties. Scalar means a physical quantity which having only magnitude and it does not require any kind of direction for the expression of these kind of physical quantities. Vector quantities are the quantities which contains both magnitude and as well as direction. Example, if scheduled examiner asks you to find out what is your weight, then if you try to express 60 kg weights or 30 kg weights like that if you are expressing, then there is no direction is specified in that particular case. Suppose if another example, what's the time suddenly if anybody will ask you, if you say that sir it is a morning 8 o'clock or a night 12 o'clock like that if you try to express, then there is no direction. So some physical quantities doesn't require any kind of direction. They are called as scalars. Mass, density, volume, area, etc. physical quantities comes under scalar nature. And whereas the vector quantities contains both direction and magnitude. Example force. For example, if somebody will ask you apply force on an object, then the question is that in what direction you need to apply the force, that is important thing. So therefore, force acting on the system, acceleration and displacement, what direction you are moving, etc. will come under examples of this particular vector group. In addition to that of this scalar and vector, we have one more type of physical quantities. They are called as tensors. What is meaning of a tensor quantity? Tensor quantities are nothing but the physical quantities which having a magnitude such that with respect to direction its value will change. Next example is refractive index of the material mu, electrical conductivity and thermal expansion of materials alpha, beta, gamma, etc. will fall in the distance of physical quantities. In rotational motion, we have a term that is called as moment of inertia I. In the later cases, we can study. So that moment of inertia I also be included in the tensor systems. Next, in this particular session, we will try to deal with the concept of vectors. So further, we will try to lead the next concept, that is types of vectors. So in the types of vectors, what are the important types? First one is we have the unit vector. Next one is we have a null vector. Next one is position vector. Next one is equal vectors, not equal vectors, coplanar vectors and non-coplanar vectors, etc. Different type of vectors are available, about 21 in the nature. Of course, we will try to use only approximately these three vectors widely. We will try to later explore what are these things. Next, how do you represent the vector? So next concept is representation of a vector quantity. Representation of a vector quantity. How do you represent a vector quantity? So the representation of vector quantity will be done in 2 dimension and as well as 3 dimension. In 2 dimension, again we have geometrical representation and mathematical representation. In the geometrical representation, we have to choose some axis like this and something like a line with the head will try to represent a vector, non-zero vector. O to A, nothing but a vector in the given coordinate system, is called x-axis, this is y-axis. Similarly, in the 3 dimension also, you can represent that this is x-axis, y-axis and z-axis. And this particular one from O to A is called one, the vector in the form of 3 dimension way. Further, in the mathematical form, the vector A bar is equal to here xi plus yj. Here A bar is equal to, because of our 3 dimension we have xi plus yj plus zk. Like that you have to represent. And what are this x, y, z? X comma, y comma, z are nothing but simply scalar quantities. That means they are simply values. And whereas I comma, j comma, k are nothing but directions along x-axis, y-axis and as well as z-axis. As we completed that, vector quantities contains here magnitude and as well as direction. So therefore let us try to find out these two things. So the magnitude of the vector given by square root of x square plus y square, and the direction is given by simply tan inverse of y coordinate by x coordinate. So we have to take the modulus here. With respect to x-axis, either clockwise or anti-clockwise. Okay, we have to represent here the direction of the vector. Here in the geometrical one, suppose I have one more vector like this. So this is called b bar. Our starting point is C, ending point is some D. CB bar vector is given by. So final vector here, x coordinates are there. Therefore, delta xi plus we write down delta yj. In this case, direction is given by alpha is equal to tan inverse of modulus of y by modulus of x. Change in values we have to take care here. So like this we can find out the direction of vector. On the other hand, in the three dimension, the magnitude of the vector is given by square root of x square plus y square plus z square. And the directions are represented by three angles alpha, beta and as well as gamma. So these three things will try to give you the angle made by the x-axis, y-axis and as well as z-axis. Okay.